we've been graphing trigonometric equations for a couple of lessons now, and one of the reasons we do this is because if you were given an equation that involves both sine or cos or tan or one of the other trigonometric functions, and we need to equate that to an algebraic function like x squared minus 1, that's very difficult to do. Our algebraic techniques that we've used in the past, things like, you know, factorizing and quadratic formulas and all those sorts of things, they don't work. And if we're talking about some of the real world applications, having an exact answer isn't necessary. If you can get an answer to 1 or 2 decimal places, then quite often that's as accurate as we need. So what we can do is we can graph the functions and find the point of intersection, because then that will give us a very good idea of what the solution to this equation would be. So you can see here we've got this equation, sine x is equal to x squared minus 1. Now x squared minus 1, generally if we were trying to solve that, we'd be factorizing and then saying x is plus or minus 1 if it was equal to 0. It's not equal to 0, it's equal to sine x. And that's quite difficult. We can't use any of our normal techniques. So what we're going to do is we're going to graph sine x, and then we're going to graph x squared minus 1. Now, you can do this with pen and paper. If you're doing that, please make sure you do it as accurately as you possibly can. You may be asked to do that in the HSC, so you will do a bit of practice on that. But at the moment, what we're going to do is we're going to use GeoGebra. And these programs can give us some very, very accurate approximations to the solutions to equations like this. So they come in very, very handy. So first we're going to look at the parabola, the x squared minus 1. Now that should be fairly straightforward. Our y-intercept is minus 1. If I factorize that to x plus 1, x minus 1, I figure out that the x-intercepts are plus or minus 1. So graphing x squared minus 1 is very easy. All right. Now sine x, this is a very straightforward trigonometric graph. It has an amplitude of 1, it has a period of 2 pi, and we know that sine x starts at 0 and then heads up. So when you graph that, you get this function. So you can see that what we have are 2 solutions because it only intercepts at 2 points, and it can't intercept anywhere else because our parabola increases after that. Whereas our sine function, periodic, it doesn't go any higher than this. So you can see our first point of intersection is just here, and our second point of intersection is over here. So this first one, if you want to have a look at that, I would guess that at about 1.4. That's what it looks like to me. So we'll put a point on there, and we'll see what it says. Yeah, it says our solution 1.4. Okay. And so then, if we have a look at this one, I would say minus 0.7, do you think? Let's have a look. I'll put a point on there. Minus 0.64. Okay, now it depends on what the question asks you. We're asked for 1 decimal point, so they would accept 1.4 and minus 0.6 or minus 0.7 for that. Some of your equations may have more than one or two solutions. It could cross 3 or 4 times or whatever. It just depends on what the functions are. But this is what you need to do. When you're doing your sketch, you need to do this carefully. You need to get a pretty good idea of where those points should be, and so your sketch needs to be as accurate as you can possibly make it. So don't take any shortcuts. If you're asked to do this, spend the extra time trying to make it as good as you can. That's what you need for exercise 5.8. I want you to focus on the first 6 questions. Okay, good luck. I'll see you in class.